Okay, so first thing, create a new project. I shall call it pumps, make it for DVP SE type PLC, save it under projects, that's all fine. Click OK and it will create my new project. Then I don't tend to use this that often, so I'm going to close that. The first thing I'm going to want to do is capture my I/O for the system. So here's a little spreadsheet I made where there's 8 inputs on the PLC for if the pump is in auto mode, if it's in manual mode, if it's running, or if the breaker is tripped. Then I've got the 2 outputs, 2 alarms, and then a couple of level sensors, which I'll get into a bit later. Anyway, I'll put that back on my other screen. Then, to capture the I/O, what I'm going to do is create a new program and call it I/O handling. I'm going to do it in ladder. It'll be a cyclic task, so it'll always run while the machine's running, and it will be active. I'm then going to capture all of my I/O here in this function block. So I'm going to take off define global, set it to not auto close, and basically just quickly capture all of my I/O. Okay, so now I'm onto the first input card over here. On a Delta PLC X, so okay, it's base 8 first of all, so it goes X 0 up to 7, then it would go up to 10 to 17. Those first 16 inputs are reserved for the PLC, so your first input card is actually going to start at X20. Put this back on the other screen. Okay, and just like that, you see I have all of my I/O captured. Now this next part's going to seem a bit redundant, but what I'm going to do is now capture all of these into marker space under global symbols. So I'm going to create a new global symbol table and call it I/O markers. And basically start capturing things again here, starting at the first marker bit, which is M0. Okay, so these are now all declared as global variables, which will be accessible by any program that I create from here on. Now going back into I/O handling, I'm now basically just going to create a simple program that takes each actual input, so say pump 1 auto, and moves it into those markers that I just created. Now, this seems a bit silly, like why wouldn't I just declare these as globals and then access them? And the reason I like to do this is that these markers might be accessed in multiple places throughout your program. Now, if you're doing the commissioning, or if there's a sensor change or something, and it turns out that, oh, actually pump 1 auto is a normally closed switch, I can flick it over easily here, but the actual handling of this flag within my program doesn't change. So little changes to things like that. Another example might be, let's say you want to put in a timer. Let's say you don't want it to switch into auto mode unless it's been on for 10 seconds. I could, put it, what should I call this? Auto timer. So timers work in tenths of a second, so 100 is 10 seconds. And then put that there and put auto timer in there. Now that marker will only come on if pump 1 has been in auto for 10 seconds. That would be an example. So let me go back to that and capture the rest of them. So another reason to do things this way is that you can put in qualifiers. So for instance, I don't want the pump 1 run signal to come on if pump 1 it's tripped. Whoops. So I'm going to use a normally closed to make sure that pump 1 will only come on if pump 1 tripped is off. At this stage I can also put in another thing here. So I know that the auto sequence is going to be turning on this flag, but if the pump is in manual mode, then I don't care about this flag. The pump must just turn on. Well, as long as it's not tripped. So pump 1 auto. Okay, so now let me create a control program. Well, actually, let's start off with level monitoring. So my I/O markers go up to M16, so I'm going to leave a little bit of space for expansion and start a new symbol and call it pump demand 1, put that at M20 and have pump demand 2 and M21 as well. So how this will work is that if we get low level 1 marker, I want to start the pump demand at pump demand 1, so I want it to set, and then if it reaches the stop level, I want pump demand 1 to go away. Oops. And basically the same thing's going to apply for low level 2 is going to start pump demand 2, which will start at the second pump. But this one must stop if it goes above low level 1. So basically we get the water level drops below low level 1, pump 1 will start and try and start filling up the tank. If it then reaches the stop level, it will stop the first pump, and if it carries on going down until it gets to low level 2, it will then start up the second pump, which will then stop once it goes above the low level. Hope that makes sense. So now I'm going to create the alarm program. So what this will do is simply, if it gets to the alarm, if the alarm level comes on, then it'll trigger the high level alarm until the level goes below there. Now what I could also do if I put in a reset input is I could have made these set when they reach these high levels, and then you could have another block to, well, reset them when that input comes in. But I'll just keep it simple for now. Okay, now I'm going to do some fancy stuff with the handling of the pump. So what I'm going to want the program to do is when one of the pumps turns off. So let's say you get a start level and it starts up pump 1. Then after a while it gets to the stop level, pump 1 stops. The next time I want it to start, I want it to start but with pump 2 rather than pump 1. So I'm going to call this duty handling. So whichever pump is the active pump will be the duty pump. So I'm going to go back to the main table, create a flag called pump on duty at M22 and pump to duty. And how I'm going to do this is that if pump 1, what should I use? Let's use the running flag coming back from the pump. If that goes down, I want it to set pump to duty and reset pump 1 duty. And do the same for pump 2 running. And then above that, I'm just going to put some handling for earlier cycles. So if either they're both off or they're both on, it will now set the first one and reset the second one. So that's kind of just some error checking to make sure that, you know, somehow both duties have somehow come on, or if you power up the PLC for the first time and both of them are off, it will just turn on and make duty pump 1 the duty pump. So now what I'm going to do is create a condition for when pump 1 is the duty pump. That okay, so now if pump 1 is the duty pump and you get demand 1, it'll turn on pump 1, and if pump 1 is the duty pump and you get demand 2, it turns on pump 2. So now I'm going to create a condition for pump 2 being the duty, which will just be the opposite of that. Okay, and then I'm going to add in 2 more checks here to make pump 2 the duty. The first is going to be if pump 1 is not in auto. Whoops. Oh, I'm having a hard time here. Or if pump 1 is tripped. So it might be an auto and, whoops, auto and tripped. Do the same for pump 2. Okay, and then just for simplicity, I'm going to add in here that this must only happen if pump 1 is in auto, and this must only happen if pump 2 is in auto. All that this flag does is just make sure that this section of code here doesn't get executed if there's an issue with both of the pumps. Could probably add in
Something went wrong. Please try again.
okay, apparently I'm setting off Siri, but anyway, can also add in, oh no, that's not what I wanted to do. Make sure that pump 1 is not tripped. Not sure how necessary this section is, but sorry what I just added now, but yeah. And that's basically it. So the last step will be downloading to the PLC. So let's try and compile it and see if there's any errors. See what I've done here. Okay, so it compiles. Then you would open up your COM manager. Let's pretend it's the first time, so you'd add a device. So I have apparently an Arduino Mega attached to this device under COM3, but you would be connected to, say, a USB to serial converter or directly via USB. You could also have an Ethernet connection to your PLC, but yeah, I don't have one currently connected, so I'll just pretend that I'm using my old driver. Oh, something cool that you can do at this stage is you can actually add a DVP simulator, which is very cool. So let's say it's an SE. Let's do that for now. So driver one, let me actually call it simulator. Okay, start the simulator. So, nope, not USB simulator. There we go. It's okay. And go online. So now it will ask me, tell me that I need to download to the PLC. Hit yes. Okay, so we want the program, so that's quite important. Then over here you can choose to overwrite the initial values if you've set that at your variable table. These over here are basically the actual code. So now if I don't select these, or if I unselect them and download to the PLC, if I upload it, instead of having the names here, it's going to have whatever their variable address would be. So the marker M, say it's 8 for that, or 7 I think it is for run. So I want to have everything. So I'll do that, transfer it to the PLC. And there you go. And now I should be able to force... No, I can't force IO. Yeah. That's basically how you do a simple pump station. Hope you found it interesting.